Hello guys, and welcome to another new tutorial on Mantaflow. So today I'm going to share with you some tricks in accomplishing your simulations in Mantaflow. So normally Mantaflow is a bit tricky when it comes to baking your simulation. So with these tricks I'm about to show you, I think this will help you in solving any situation you face in the future. Alright, so this is an empty scene. So obviously we'll be adding a cube. Yeah. Alright, so we are going to scale it a little up. Alright, so scaling it up and maybe on the Z. Okay, cool. So let's change this to wire. Display wire. Alright, cool. So this is going to be the domain. Let's add another cube. Alright, scale it down, something like this. Then move it a little up. Alright, cool. Alright, so let's add the physics to it. So it will be fluid flow under smoke. Under flow type we choose liquid. Geometry will do. Initial velocity. Okay. Alright, so this option helps you to get some randomness in the flow of the liquid. So we are going to change the flow behavior to inflow. Alright, so the fluid is going to flow out from this into the domain. Alright, okay, so let's add a domain. Fluid domain liquid. Alright, what else 64. Okay, so we are going to go for the default setting. So we are going for the default settings. Very simple, then bake. Alright, so let's go to wireframe. Let's see what we have here. Alright, oh cool. Alright, so we have the scene ready for the tricks I have for you guys. So firstly we are going to work, the first trick will be the outflow height. Alright, so one thing I've noticed about Mantaflow is when the inflow height, so when the inflow is generating the fluid into the domain, the fluid actually reaches the height of the inflow. So if this simulation was supposed to be like 200 frames, so let me change it and bake it, resume. So whilst it's baking, so what I was saying was the inflow height is the height of the simulation or the liquid it pours out. So if the height or the height of the inflow is at this level, obviously or normally at in a normal circumstance, the height of the fluid will reach the level of the inflow. So let's wait for this to finish baking, then I will do some tests and hopefully we'll get alright, good. So the simulation is done. Let's play this and see what I was talking about. So you guys can see the liquid is actually at the level of the inflow. Alright, so maybe in any case, or you will be wanting to have the liquid at this level, at maybe at this level or at this level. So what's actually causing this is the thickness of the liquid or the fluid which is being emitted. So the way to solve it is under first select the domain, then under diffusion, let's first free data. Alright, so under diffusion, alright, good. Under diffusion we have these two settings. So we have the exponent and the base. So the lower the number here, the how should I put it, so the higher the number here, the thicker the fluid will be, and the lower the number here, the thicker the fluid will be. So it's actually opposite. So if let's say here is 0.1, the fluid is going to be very thick, resulting in higher simulation in terms of the height. And if the exponent is high, something like 9, it will also add up to the thickness of the simulation or the fluid. So to get remember the first test we did, the level was at this place, which is at the level of the inflow. Alright, so at this place, so let's do another quick baking and see the results we'll have. So I'm going to decrease this to 0, then I'm going to increase this to 9. Alright, so let's bake and see the results we will have. So bake. All right, so we are done, and now you can see the level we have now. So the first test was at the level here, and the second test is at the level here. So that's a way to reduce the height of your simulation. Alright, so another trick to reduce the height is actually to move the inflow down, because since the height is normally determined by the location of the inflow, moving it down will also reduce it. So but we don't need to do any test, because I think the first example or the first baking we did um, um, proves it, so we don't need to do any test for that one. So that's the two ways of reducing the thickness or reducing the height of your simulation after you bake it or when you're about to bake it. Alright, so the next trick was collision errors. So we are going to um, add a plane, um, scale down something like this, and maybe rotate it like so. Alright, so um, so flow, liquid, geometry, effector, sorry. Alright, alright, so let's try and bake it and see whether the simulation will collide with this. So for this we are going for only 80 frames, 80. Alright, so select the domain, then change here to 80, then let's bake free and bake. Alright, it's done, so let's see whether it's going to collide. And no, no, it's not colliding. It's not colliding. So the way to fix this is actually um, to increase the surface thickness here. So let's go for something like 0.7, because it's too thin for the collision to notice there's notice there's an object here. So 0.7 will actually be a good help. So let me bake again and I'll be with you when it's done. Alright, free data. Alright, so it's done, so let's see whether it will collide with the plane. Awesome, so you can see now it's colliding with the plane, and wow, cool, right? Alright, so that's the trick for the collision. And the next one is the flip normal. So let's create a scene for that one. So we are going to delete this, delete, and then we will let's add a sphere. Alright, so let's give this one a flow, then liquid, then geometry. So this actually going to become a fluid itself when it's big. So it's not going to emit any fluid, but the whole object will turn into a fluid. So that's the flow behavior, and that's the effect the geometry gives. Alright, so let's bake and see the results, whether it will work. So now this one is supposed to work, but let's see whether this one will work. Then we will try a different approach and see why that one wasn't working and a way to fix it. Alright, so it's done, and you can see the fluid is inside the sphere. So let's delete this one, and let's add a plane. Alright, and then let's switch to edit mode. Okay, and turn on normal face. Normal. Face. So let's subdivide this. Alright, so now you can see the normals are pointing upwards. Alright, let's extrude this. Extrude. Let me use the shortcut. Alright. Okay, so you can see we have the normals here. The numbers are pointing at the right direction, but normally, or sometimes after extruding, you get the normals pointing at the wrong direction. So you get something like under mesh normals flip, you get something like this. So if the normals is pointing inwards, the simulation will not recognize this as a liquid to generate the fluid for it. So let's try and bake this and see whether Mantaflow will recognize this shape. Alright, so first let's add the flow geometry, switch to liquid. Alright, cool, and let's bake free data, then bake. So we can cancel it because we just want to see whether it will work, and nothing is there, right? Nothing is there. So let's go back again and flip it. Alright, and let's bake. Select the domain, free bake, then bake. You can pause it. Let's see. Alright, so it's falling at the first frame. So you can see now it's working. We have the fluid falling out of it. It's very quick, so we didn't get it at the exact position, but you can see it's working now. So that's a way to solve any error you find when trying to get a fluid out of geometry. Alright, so my last point was scaling. So in the previous version of Blender, which is the beta version of Blender, scaling actually affects the simulation process or the baking process. So if your object is actually is having a value of 8 Blender units, I'm talking about here, is having something like 8 or 9, the simulation won't work. But if you have something less than 8, then the simulation will work. But it seems now it's fixed, so that's a good thing. So that's the end of the tutorial. Have a nice day, and thank you for watching. Bye bye.